Good morning, students. I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So, in this video class, I am going to teach you about NFA to DFA conversion. That is the theorem deals with the equivalence of finite automata. That is NFA to DFA conversion. So, you have to understand there is no DFA to NFA conversion. The only thing is we can convert from NFA to DFA. So the reason why we don't have DFA to NFA conversion is NFA can act as DFA because from the definition itself I told you NFA, the definition is the control moves from one state to another based on the external input, but the input it reads one time, 0 time or one or more times. Okay, so one time means it comes under DFA. Okay, so NFA can act as DFA, but DFA cannot act as NFA. Okay, DFA has some structure. So we can convert NFA to DFA. You keep in mind there is no problem DFA to NFA conversion, only the problem NFA to DFA conversion. Okay, so we'll see the question, convert the following NFA to DFA. So this is very important 16-mark question. If you see the problem NFA to DFA conversion, you should verify the given transition diagram, or they may be give transition table, something is NFA. Okay, so you have to verify the given transition diagram is NFA. So last video class I taught you how we can verify this is NFA. See, that's what I am mentioning here. So the state Q0, it read the input 0 2 times. Okay, see Q0 0, it goes to Q0, and Q0 0, it goes to Q1. So it read the input 2 times. So it means this is have non-deterministic finite automata, because I cannot determine Q0 0 where it goes. It goes Q0 as well as Q1. So this comes under non-deterministic finite automata. So you have to verify the given problem or given transition diagram is NFA. Okay, so this is NFA because 0 it reads 2 times. Q0 it reads 0 to solution. We have to understand there is a 4 steps method you have to remember, then only we can solve this problem. The first one is subset construction. Subset construction. Second one is transition table. Third one is transition function. Fourth one is renaming states. And last one is transition diagram. Okay, so if you follow this 5 steps, you will get NFA to DFA conversion. Okay, and renaming state is one of the optional state. Okay, I will tell you why the renaming states we have. Right, so first we will solve subset construction. So how we have to solve the subset construction method is, first we have a formula P of n equal to 2 power n. Okay, so the n means it is a number of states. N means number of states. So we have how many states? The given problem we have 3 states. See Q0, Q1, Q2. So n stands for 3. So 2 power 3. Okay. So if there is a 4 state, it comes 2 power 4. So 2 power 3, that is equal to 8. Right. So P of n equal to, we have to form 8 subsets. 8 subsets. Okay. So first one is empty set. I can mark it as like this, or I can mark it as like pi. Okay, anyway, empty set. First one is empty set. Second one is Q0 alone is one set, right? So Q0, and Q1 alone is one set. So Q1, and Q2, similarly Q2 alone is one set. Then Q0, Q1 is one set. So Q0, Q1 is one set. then Q1 Q2 is one set, Q1 comma Q2 is one set, and Q0 Q2 is another set, that is Q0 comma Q2 is another set, then Q0 Q1 Q2 is another set. So Q0 Q1 Q2 is another set. So how many sets I have? 8 subsets. See, 1 2 3 4 5 6 7 8. So how I derived 8 subset? See, Q0 alone is one set, Q1 Q2, then Q0 Q1, Q0 Q2, Q1 Q2, then Q0 Q1 Q2, and empty set. So I will get 8 subset. Right? If there is another one set, I will get 16 subsets. Okay. So first one is over, subset construction is over. Then another one is transition table, right? Transition table. So we know how to construct a transition table. This column wise we have states, right? So first video class I taught you how to construct a transition table, and this row wise we have input symbol. Okay, so column wise we have state. So this is state, this is states, and this is input. Okay, this is state and this is input. So how many inputs I have? 2 inputs. What are they? 0 and 1. So this is 0 and this is 1. So only 2 input. And how many states we have to draw is, what are the possible subset we got? All the states we have to mention here, because while constructing a transition function it is needed. Okay, so first one is empty. I will mark it as pi, or I will mark it as empty set, and then Q0, and then Q1 and Q2 and Q0 Q1, Q0 Q1, Q0 Q1 Q2, and Q0 Q2, and Q0 Q1 Q2, Q0 Q1 Q2. Okay, so this is the transition table. We have to fill all the transition table. Okay, so first one is empty. So empty pi. Okay, empty, that is empty 0, empty 1 is also empty. And second, Q00, we have to see the transition diagram. What is Q00? See, Q00, it goes to Q0, and Q00 it goes to Q1. So 2 states I got. So Q00 goes to Q0, Q00 goes to Q1. So here it will come Q00 is Q0 comma Q1, Q00. Okay, once again, Q00, I want to see the transition diagram. Q00, it reads 0, goes to Q0. Similarly, 0, it goes to Q1. So I got Q0, Q1. And Q01, Q0, it reads 1, it goes to Q0. So here it is Q0. Okay, Q1, 0, there is no Q1, 0, Q1, 1 only there, there is no Q1, 0. So it is pi, empty. And Q1, 1, yes, it goes to Q2. So it is Q2. And Q2, 0, there is no Q2, 0. So empty. And Q2, 1, there is no Q2, 1. It is also empty. Okay, Q0 comma Q1, 1. Q1, 0. Sorry, Q0, Q1, 0. So this is very important. You have to check Q0, 0 as well as Q1, 0. Can you understand? So if it is Q0, Q1, Q2 means Q0, 0 we have to check, Q1, 0 we have to check, Q2, 0 we have to check. Okay, now Q0, 0, that is Q0, 0, it goes to Q0, Q1. So Q0, comma Q1, again we have to check Q1, 0. Q1, 0 is not there. So Q0, Q1 alone. If there is Q1, 0 is something, we have to add Q that also. But here Q1, 0 is not there. So Q0, Q1 alone. Okay. Similarly, Q0, Q1, 1. So what are the things I have to check? Q0, 1 I want to check. Q1, 1 I want to check. So Q0, 1 is, see Q0 it reads 1, it goes to Q0. So Q0, 1 is Q0, and Q2, 1, there is no Q2, 1. So Q0 alone. Okay, since it is set, we have to mark it as set. And Q1 1, Q2 1. Q1 1 is there, that is Q2. Q1 1 is there, Q2, and Q2 1 is not there, so Q2 alone. Q0 1, Q1 1. Q0 1, it is Q0. Q1 1, it is Q2. Similarly, we have to fill all the things. Q0, Q2 0. So Q0 0, it is Q0 Q1. And Q2 0, there is no Q2 0, so Q0 Q1. Q0 Q2 1. Q0 1, it goes Q0. And Q2 1, there is no Q2 1, so Q0 alone. Q0 Q1 Q2 0. Q0 0, Q0 Q1. Q1 0, Q1 0, no Q1 0. Q2 0, there is no Q2 0. Now Q0 1, Q1 1, Q2 1. Q0 1, it goes to Q0. Q1 1, it goes to Q2. Okay, so like this you have to fill the transition table. So this is also over, transition table also over. And renaming state is optional, so we can rename this same table by giving another one name, that is, see, I will rename, this is 0, this is 1, and empty. For a Q0, I can give A, Q1B, Q2C, Q0, Q1D, E, F, G. So this is an optional one. This is state, this is input. Okay, now A comma 0, A is nothing but Q0, Q0 comma 0, that is Q0 Q1. So Q0 Q1, already I rename it as A, B, C, D. So here it is D, and A comma 1, that is Q0 comma Q0, already I name it as A. Okay, similarly you have to fill this table. So this is optional one, right? If you want, you can fill this or you can leave it. Okay, this is optional because some books you can see renaming state, right? So we can leave that also. If you need it, you can fill it, right? So third one is, this is optional, transition function. Transition function is very important. We have to take a starting state first. Which one is starting state? Q0 is a starting state. So Q0, we have to take Q0 and we want to mark it as A. Okay, transition function. Starting state we have to take and it is marked as A. Then we want to see the transition of Q0. How many input I have? 2. Q0, 0 where going, Q0, B where is going. Okay, so I'll write as delta D of, since it is DFA, A comma 0 transition I want to check, and delta D of A comma 1 transition I want to check. Right, A is nothing but Q0. A is not the Q0. So A comma 0 I have to check, A comma 1 I have to check. That means Q0 comma 0 I want to check, Q0 comma 1 I want to check. Right. So first A comma 0, that means Q0 comma 0. So Q0 comma 0, it goes to Q0 Q1. So I will write Q0 comma Q1. Okay. And this is old, not old state, this is new state. If I get Q0 alone, I want to mark it as A. But I got a new state, that is Q0 Q1. So I want to mark it as B. Okay. Now A comma 1. A is nothing but Q0. Q0 comma 1. Q0 comma 1, that is Q0. Okay, Q0. So this is old state or new state. I have to check A. A is Q0. So this is old state. That is nothing but A. Okay. You don't, this here only it is very important. You don't give C. Because if you give another new state, it will go the step is going somewhat longer. Okay, that is wrong. So if it is a old state, you have to mark it as old alphabet A. Okay, and now this is over, and I got a new state B, that is delta D of B. B is nothing but, that is B comma 0, and delta D of B comma 1. I want to check it. Okay, B is nothing but Q0 comma Q1. So Q0 comma Q1, Q0 Q1 comma 0 I want to check. So Q0 Q1 is there, 0 Q0 Q1, right? Q0 comma Q1. So what is Q0 Q1? We have to check it is new state or old state. This is old state, that is B. Okay, and B comma 1. B is nothing but Q0 Q1. So Q0 Q1 comma 1. Q0 Q1 is there, 1 is there. It is Q0 Q2. Q0 Q2. That is Q0 comma Q2. This is old state or new state? New state. See, A is Q0 and B is Q0 Q1. This is Q0 Q2 and again A, again B. So this is new state, I have to mark it as C. Can you understand? Right. So since I get a new state, I have to go for one more step. Delta D of C comma 0 and delta D of C comma 1. What is C comma 0? C is nothing but Q0 Q2. So Q0 Q2 is there, 0 Q0 Q1. Q0 Q2 comma 0 is Q0 Q1. So Q0 comma Q1. This is new state or old state? We'll check. A is Q0, B is Q0 Q1. So Q0 Q1. This is B. Okay, old state. And now C comma 1. C is nothing but 0 Q0 Q2. So Q0 Q2 comma 1. That is 0. Q0. So I will get Q0. This is old state or new state? Old state. That is Q0. So that is A. Okay. So A over A comma 0 and A comma 1 is over. B comma 0 1 is over. C comma 0 1 is over. So I didn't get any new state. If I get a D, I want to go for D comma 0, D comma 1. So I didn't get any new state. Okay. That's what I told you. You don't give the alphabet as your own wish. Okay. So if it is a new state, you have to give a new alphabet. If it is not a new state, you have to give the old state alone, right? So transition function is also over. That is this state is also over. Now last one is transition diagram, right? So how many states I got is A, B, C, only 3, right? A, B and C. Here I have to mark which is starting state and which is accepting state. That is very important. So here which is starting state? Q0, that is A is a starting state. So I have to mark it as one arrow, with one arrow. A is a starting state. Okay. So I have to mark with one arrow A. Which one is accepting state? Whenever here in this problem Q2 is an accepting state. Whenever Q2 comes, that everything is an accepting state. Okay. So I have to check A whether Q2 is there. No. In B, whether Q2 is there? No. C, Q2 is yes. I have Q2 here. So Q2, C is an accepting state. Can you understand? Yes. Okay. Now, I have to draw transition, right? So what is Q0? That means A comma 0. A comma 0. It goes to where? B. So A, it reads 0. It goes to B. Okay. And A comma 1, A it reads 1 goes to A. So like this, A it reads 1 goes to A. See, A it reads 1 goes to A. And B it reads 0 goes to B. So B it reads 0 goes to B. And B it reads 1 goes to C. So B it reads 1 goes to C. And C it reads 0, B. So C it reads 0 goes to B. C 0, B. C 1, A. So C it reads 1, it goes to A. Okay, so now this is DFA. Yes, this is DFA because we have two inputs and all the state should be read that input exactly one time. See A 0 one time it reads 0 and 1 also one time it reads 1. And B also reads 0 one time, 1 one time. C also reads 0 one time, 1 one time. But here this is NFA. See Q2 it doesn't read any 0 and also 1. So this is NFA. So it has structured DFA. Hope you understood, right? So in order to convert NFA to DFA, we have to follow these steps, right? And how we'll confirm this is DFA for this NFA? Yes, we can confirm. See, if I give a string 0, 0, 1, I will ask whether this string is accepted in this NFA. Yes. See, it starts with the 0, 0, 0, 1 and end with the Q2. So NFA it is accepted. So if it is accepted NFA, it should accept a DFA. because we are constructing DFA from this NFA. So it should accept, then only it's true. We'll check. See 0, 0, 1. See finally it accepting state. It is accepted. Okay. And again, whether 0, 0 it is accepted, 0, 0. Whether 0, 0 is accepted as DFA, sorry NFA. See 0, 0. It is not accepted. It is in Q1. Similarly, here also it won't accept 0, 0. See, it starts with 0, 0, 0. It ends with B. It is not accepted. When will we say it is accepted? Whenever the string it reaches accepting state, then only it is accepted. Okay, so whenever the string accepted in this NFA, it should accepted in this DFA. Whenever the string not accepted in this NFA, it should not accepted in this DFA. Can you understand? So because we are constructing the DFA from this NFA. Okay. And one more thing you have to consider, very important thing is, while constructing a transition table, we have to mark it as starting state and accepting state. So starting state is, we have to mark it as like this arrow, starting state Q0, and accepting state, whenever Q2 comes, that everything is accepting state. This is accepting state, this is accepting state, this is accepting state. Since Q2, Q2, Q2. So this is also accepting state. We have to mark this star. Okay. So this is the way to convert NFA to DFA. Right. We have more problem. We'll check it. All the problems are NFA to DFA. And we want to check the given string with the NFA, and the string is accepted by the NFA and the string is not accepted by the NFA. Okay. We'll see the next video class for solving more problems. Thank you.